Good afternoon, everyone. Thank you very much for joining us on this, our first of our series of cybersecurity webinars. Today, our presentation will last approximately 30 minutes, and then we'll have an opportunity for a Q&A session after that. However, before we start, I just want to quickly go over some housekeeping rules. Firstly, everyone will be has automatically been placed on mute, just to help us reduce any background noise. Secondly, you should see the little Q&A chat room. If you have any questions at all during the session, please put your questions into there, and we will get to all of those at the end. And lastly, the presentation, the webinar, is being recorded. As soon as that is available for on-demand viewing and downloading, we'll send you an email so that you can access that at your own leisure. Today, our speaker is Sven Nowak. And Sven's been with TÜV SÜD for about 17 years now, since 2004. And he's held many roles in many different locations, including Germany, Japan, Singapore, and currently based here in the US in Alpharetta in Georgia. But he's probably better placed to tell you more about himself. So I'm going to pass over to Sven, who will give you a wee bit more about his expertise and experience, and to kick off today's presentation. So over to you, Sven.
Yeah, thank you very much, Jim. And good afternoon to everyone, or good morning to the ones joining from the Pacific, from the West Coast. So let me start with the presentation. Today, we are talking about consumer IoT cybersecurity, and my objectives of today's meeting, or of today's webinar, is really that you walk away with a better understanding what IoT devices are, what the challenges associated with cybersecurity are, what is the status quo on where we are at the moment from a standard and a regulatory perspective, what are ways to manage risks associated with IoT devices, and really to give you a picture where the journey goes. Before we start to get into the details, allow me some general things, or some definitions here. IoT is, or the term IoT, Internet of Things, is all around us, and there are many definitions, so some are better than others. I put out here two definitions that I found quite specific and quite precise what Internet of Things actually are. What it is it can be any device, as it mentioned here, with an on and off switch, which is connected to the internet or is connected to other IoT devices. In other words, it's a giant network of connected things and people. So this can include everything from cell phones, from coffee makers, from washing machines, headphones. I think we all know thousands of examples here, and every device, so that it has the term smart in front, is potentially an connected IoT device. In this giant network, we have those connected things, and those things collect data. They share data with other devices. Examples here could be a temperature sensor, as an example, could be a voice controller. We'll give you some examples later, or more examples later. Those devices or other devices analyze and process this data. So that could be the control system of my air conditioning, or any control system that analyzes my voice commands. And then I have devices controlling my environment. This could be the smart light switch, the smart thermostat as an example. So those are, so when we are talking about Internet of Things, are really this giant, this massive network on those IoT devices. Some examples. So I mentioned some of those in my previous slide, and again, I think we can all find one or the other device listed here on this slide that we already use in our household. When you go through this top IoT device list or the top sellers, so to speak, in 2021, we have devices like home voice controlling devices as an example. So those are smart devices which allows the user to control any sort of house instruments, such the alarm system, the lights, the thermostats, or others. They allow me to control media. They're capable to run songs, to control the volume, and they have many more functions. We have smart locks as an example, which are locks allows the user to manage the doors from any locations, basically to see and to manage who comes in and who goes out. Gives me the status of the door, so whether it's properly closed or not. Has the so-called auto unlock feature that we know from cars, for instance. So as soon as the user arrives near to the door, it opens automatically. And all those features where we think it is something that we really need. I mean, we have different opinions, I think, on that. I read, actually, when I looked at smart locks, I read in an advertisement the other day a slogan that says it provides unlimited digital keys and no fear of stolen keys. So this certainly relates to physical keys, of course, and we will also learn how much this relates and how much relevance so this slogan has in terms of digital keys. So whether it can be stolen or not. We have light switches, so that help the user to manage home lights from your mobile device or by using your own voice. We have smart lighting system that allows really to control the lights and to create the right ambience for every moment. So it's synced with music or with movies as an example. So we have smart plugs. We will get an example later on a hack on the smart plug. As actually, it can turn on your lights, any sort of appliances. It can monitor devices. It can schedule a usage for energy efficiency. See as an example. Apart from consumer devices, IoT also applies certainly to all other verticals as well. We have industrial devices, all the smart components so that you use for machines as an example. We have medical devices and so on. So today, the focus will be more on IoT devices in general and consumer IoT devices in particular. Very quickly, we hear a lot of information about IoT and how important it gets in our life. And I think there are a lot of statistics out there, and sometimes you have also statistics which are not consistent and where you get different data. But I think one thing is for sure. So whatever data we see, it all shows the same direction. IoT is on the rise, and I think it is fair to say that this is an undisputable fact. I put some numbers here. So, for instance, that the IoT analytics experts, they predict that the global number of connected IoT devices grow to 12.3 billion active endpoints in 2021. And this is, I saw also other numbers, so this is a quite conservative estimate here. I saw numbers which suggest much higher numbers of IoT devices. we will reach 27 million by 2025. And when you put this into the perspective of the world's population, which is currently at roughly 7.6 billion, I think, humans on this planet, and to put this into the perspective of the usage of the IoT devices and the number of IoT devices, I think it speaks a clear language. Economic value also has where IoT solutions have the potential to generate up to 11 trillion in US dollars in economic value by 2025. Again, there are numbers which suggest more or less, but again, it's something that really shows the direction where IoT devices will bring us. What I personally find very amazing is also the amount of data that is generated by IoT devices. It's expected to reach more than 70 zettabyte by 2025. Actually, I had to check myself what the zettabyte actually is. A zettabyte is read as the 2 to the 70th power bytes. So that equals to 1 billion terabytes or 1 trillion gigabytes. So just to have an idea on the data that we have to so that we produce, that we collect, so that we share, and that we process. So in simple terms, it means that we need 1 billion 1 terabyte hard drives to really store all of this data. So this is quite an amazing development. I think the advantages of IoT devices they are quite clear to us. It provides a good automation and control. It saves a lot of time and money. It increases efficiency. It helps to save money by reducing manual tasks. It just gives us a better quality of life. So I think those advantages are clear. I think those advantages are what we see in those IoT devices. Although there are several advantages, there are also certain disadvantages too. Internet of Things devices does not have international compatibility standards as an example. So this creates challenges. They also become more and more complex in terms of functionality. And with complexity, or with increasing complexity, the failure probability increases as well. So there's a certain concern also about reduced safety for users. Putting this aside, because we're talking about cybersecurity, devices also increasingly affected, or IoT devices are increasingly affected by privacy and security breaches. I think this is where what our presentation today is all about. The IoT cyberattacks on IoT devices, they doubled in the first half of the year. They doubled from 639 million breaches in 2021. At the same time frame in 2020, in 2020, and in the same time frame 2021, they doubled to almost, or to more than 1.5 billion breaches. There are security concerns, and there are different types of attacks. So we distinguish between 3 major types of attacks. So first is the direct attack resulting into direct damages. So what could it be? So it's the hacker that hacks the alarm system, as an example, of your house and disables the alarm system. So it's a direct attack to your alarm system with a direct damage then to the alarm system. Or it's a hacker attacks the connected thermostat of your heating system and disables this, overheats the house, or whatever harm the hacker wants to do. So those are examples of direct attacks that create direct damage. So this is what we think as a user is typically one of the major concerns so that users typically have. So, and this is what the perception is. Sometimes I have a device in my household and this device is hacked and creates some damage. But there are further concerns or even more concerning attacks that are used to use IoT devices just as gateways to attack other devices in my household, as an example. So we have the so-called stepping stone attacks. So the stepping stone attack is where hackers execute attacking commands from an intermediate compromised host. And this host, this host is also called the stepping stone host. Typically, the attacker remains anonymous. And as an example, when an attacker compromises your voice controller, he can use then the voice controller to turn off or on your alarm system. So it is the voice controller will then become the stepping stone host, so to speak. As you can imagine, the voice controller, as an example, has many other connected devices to the voice controller that can be potentially compromised by a stepping stone attack. In this kind of scenario, we need to detect the stepping stone host, and we have to try to break the attacking path from the controller to the alarm system to use our earlier example. Thirdly, we have the so-called botnet. So the botnet term is derived from two words, from robot and from network. So it is mostly a collection of internet-connected devices that are infected and controlled by a malware. A bot is then a device infected by a malicious code, which then becomes part of the network, or the so-called net, of infected devices, which can then be all controlled by an attacker. You may have heard the term zombie or zombie army as an example. So a bot is sometimes called a zombie, and a botnet is sometimes referred to as a zombie army. A couple of examples. So here, so those are real examples, and some of the examples, if you I put when we share the slides with you later on, so you can use the links here provided on this presentation slide to get further, more detailed information on those particular hacks. It's here an example of a smart security camera. So the camera was installed in children's rooms for to as the user of this particular case said to have a peace of mind. So when you check out the reference link, you will find a very disturbing story about this particular hack of the camera, where the hacker instructed the child to do harmful things, actually. If you read it, this is very disturbing stuff. But so those things can happen. So, so many consumer IoT devices are sold with universal default usernames and passwords. So you may have seen also on devices so that you have bought something that you have to type in admin as an example, as your credential, and password will be then again admin or password, so 1, 2, 3 or whatever it is. So those typical things, so that IoT devices have universal default passwords and usernames. Which is, so you may say, okay, so this is something that can be easily fixed. I mean, this is quite obvious. So that standards, as the cited 303.645 has requirements for those passwords, so that equipment should not have universal passwords. But we are not just talking about the consumer or the password to identify, or which is defined by the user, or to authenticate the user of the device. There's also passwords available or credentials, so which are shared among devices, which you as a user don't even have control of or even knowledge of. So also here we have sometimes situations where default passwords are used for machine-to-machine or device-to-device authentication, and this is out of our control. So this is a typical example of a direct hack. I hack the camera and I create direct damage to this particular device. A second example is the smart plug, where vulnerability in the Wi-Fi connected outlets allowed a remote attacker to take over, other IoT devices and to execute code which potentially expose consumers to ransomware, to information disclosure, or what they also call the botnet enslavement. Here in this particular case, the attacker used a vulnerability in a universal or common plug-and-play software library that then leads that the attacker could then take control of this device. At the very basic level, the flaw allowed the attacker then to switch on and off devices, which I think is all agree is not nice. It's a nuisance, but not as critical as we may have thought. But then further exploitation of the vulnerability can then also grow the potential threat. So if the plug is connected with other devices in the household, as an example, in this particular case, what was connected to the network router. So the smart plug could be used to access or to poke a hole actually into the network router, and then allow attackers to connect remotely and unnoticed to any of the devices connected to the network. So there was an example of a stepping stone attack where the smart plug was used as a stepping stone host. So also here, a potential mitigation is to follow requirements out of one of the most common cybersecurity standard to monitor and identify and rectify security vulnerabilities within products and services so that I sell or produce. This particularly also applies for third-party products, services, open source software, etc. A third example is then one of the botnet attacks. So here, where is the so-called MOSI IoT botnet, which is interestingly around for many, many years now, but it's still used to distribute the notorious peer-to-peer botnet MOSI. This is where the botnet that uses this BitTorrent, so which is a communication protocol, and exploits weak telnet passwords or other vulnerabilities, and then to conduct so-called distributed denial of services, data exploitation, payload execution, and so on. So here, an example where you have those botnet attacks where attackers potentially can remotely control a number of IoT devices in the network. Impact of vulnerable IoT devices, we discussed three of them. So first of all, we have the personal privacy. We had examples, we heard examples where attackers were listening to voice control commands in the household. So whether it was the microphone of the smart TV or it was anything else, there were, other means by equipment that use LiDAR as an example, which the LiDAR sensor could be also misused to listen to voices. Personal privacy is, I think, one of our major concerns. So second one is the product security. So whether it's the smart bolt lock in my door or my security system, or other areas where a potential breach could really create serious damage and could harm me. So second, what we discussed was the distributed denial of service, where in fact the attack would just make my devices inaccessible and unavailable, which in some areas will just create a nuisance, but in other areas it can also have safety and security impact. So when I look into the past, into why is there a lack of security of IoT devices nowadays? So why are we where we are at the moment? So this picture here gives us a little bit a glance from the past. In the past, there were not many IoT devices on the market. So what in the cybersecurity world is called the small attack surface. So not many assets, not well sophisticated assets from the connectivity standpoint, and certainly also from the functionality standpoint. So in other words, there are low incentives for hackers or for attackers to exploit IoT devices and to create harm. So keeping the attack surface small or as small as possible is one of the basic security measures actually, so that we have. So if I have a small surface, I have not much customer demand. So the customers, the consumers are used to be not very aware of cybersecurity concerns. So were not the regulation or the regulators and the standardization committees. So there was a certain delay based on the fact that there was not much of an incentive to work and develop. So this leads then to very low motivation also with suppliers and manufacturers, very low incentives to invest into cybersecurity programs or to get prepared and to get the people prepared to say, okay, we will get to that when the problem really occurs. Plus, there was also a very unattractive cost-benefit ratio at the time. So this all results into the lack of security of IoT devices, what we are currently having. So nowadays, however, the picture has changed. So the attack surface that I mentioned earlier has increased massively. So, and creates now a lot of incentives also for the attackers. So attacks are growing, and we have to be careful. We have to be prepared for this situation. So this increased the customer or consumer concerns. So consumer are increasingly concerned about cybersecurity. I will have a slide for that later. And of course, also regulators and standardization committees now have looked into this issue, and regulations for IoT devices has been released, especially over the course of the last 2 years. A lot of development can be seen in various regions of the world. And also, of course, the standardization committees, so that they worked on cybersecurity standards. Now we have incentives. We have a high motivation to invest and prepare in cybersecurity. Now we are confronted with overwhelming amounts of standards and regulations and requirements and timelines, and really to make up the time that we haven't done anything is now difficult. To find the right entry point, to make sense out of out of the regulations, to really have someone guiding me through the jungle of regulatory requirements and standards. And certainly the benefits and the costs are now, or the benefits are outweighing the costs now. As you can imagine, all breaches, all minor breaches nowadays are public. I mean, you have to report breaches. There are internet pages where you can see what product from what manufacturers has won, so what vulnerability. There's a lot of reputation now at stake, a lot of costs associated to that, plus also the cost that I have as a follow-up cost when I have a breach, when private data is leaked or is made available on the internet. So there's a lot of costs involved when I experience cybersecurity breaches of my products. So just to give an idea of the buying decisions of the consumers, there's a study from 2019, and I guess it's still even the consumer concerns are even bigger nowadays. So question 4 suggests that security becomes a very important buying criteria for consumers. In question 5, if you plan to purchase a connected device, will you research security prior to purchasing? And here it's also the expectation, gives a clear picture on the expectation, saying I don't necessarily, there's only half of the, or less than half of the consumers saying, no, I do the research. Why? Because there's an expectation of the consumers towards the manufacturer, so that security becomes one of the features of the product so that I buy. So a clear consumer expectation here. Question 7 is also, makes it quite clear we cannot rely on the consumer being responsible. So to rely on consumers changing password on a regular basis, to monitor vulnerabilities on the internet, to make sure that the devices are updated, we cannot rely on them, because so they see the responsibility clearly with the manufacturer, and we have to, as a manufacturer, so we have to make sure that we have mechanisms in place to get really the user out of the equation in terms of how much I can rely on them. Certification schemes, such as the CSC certification scheme from TÜV are one of the schemes or enabling schemes, and we'll get to this a little bit more in detail later. One of the schemes really also to increase trust among consumers in terms of cybersecurity. So when we're talking then about the second driver, so the first was the consumer itself, the second driver are regulations. So regulations are in the cybersecurity area are driven by 3 main aspects. So one is the data privacy, is the cybersecurity itself, and it's also safety. So when we start with privacy, data privacy, we have examples such as the General Data Protection Regulation from the European Union, the GDPR. We have some similar privacy regulations or acts here in the US, as an example, the CCPR, the Consumer Privacy, the California Consumer Privacy Act. I will talk to them a little bit more in detail later. So we have on the cybersecurity side, we have also Cybersecurity Act. As an example, here is the regulation from 2019 in the European Union to establish a common framework for EU-wide certification or cybersecurity certification. We have cybersecurity standards such as the EN 303-645 to name one. In the US, we have the NIST 8259 as an example. Those standards specify cybersecurity requirements for IoT devices. And then we have other directives, such as the European Radio Directives, as an example, the Low Voltage Directive, that typically cover health and safety risks, or electromagnetic compatibility in case of the ROD. But they will also now make reference or provision for cybersecurity as well. So if I have to be compliant with those directives in the near future, I have to make sure that cybersecurity is also one of the things I need to be compliant. I have typical safety standards, such as the IC 60335 as an example, which deals with safety of electrical household appliances. Also here we have annexes now that also lays out requirements for cybersecurity. When you look at the landscape now, on the global landscape in terms of what are global IoT cybersecurity regulations. So you can see, and those are just examples here, and this the map could be much more complex and much more confusing. We have a lot of regulations out there. We have a lot of labeling schemes out there. We have mandatory schemes. We have optional schemes, which will become mandatory quite soon. As you can see, it is quite complex, or can get quite complex to place products on international markets. And there's a certain dynamic to it. So I really need to understand if I act globally, if I want to export product to various regions, it gets very complex when it comes to IoT cybersecurity requirements. From those requirements, so you can see they are in all those three areas that I mentioned in an earlier slide. So they have their privacy, data privacy regulation, their cybersecurity standards and safety, and regulation driven more out of the safety from safety standards, such as the Radio Equipment Directive in the EU. We have certification schemes, we have labeling schemes. Again, it is something that is very complex, and we need to understand also what we need to do actually to go abroad and to export products to various regions. Just as an example, we talked about so very briefly about the General Data Protection Regulation from the European Union. Is enforced or was enforced in May 2018, and really is applicable to everyone who wants to sell products or provide services in the European Union. And whether you're physically present in the European Union with your company, or you just store or process EU citizen data, you have to be compliant with this regulation. And as you can see, the enforcement is quite harsh and can lead to a lot of penalty payments. So here, just a couple of examples. I don't want to go through this in too much detail as we are running out of time. Breaches of these regulations can lead to very significant fines. If you're interested, there's the so-called GDPR enforcement tracker. I provide a link here where you can see who breached the GDPR regulations and what penalty and what fine has been handed out. We have the California Consumer Privacy Act enforced from January 2020. A similar setup like the GDPR. Really to give consumers more control over the personal information that businesses may collect about them, including the right to know about the personal information, the right to have them deleted, the right to opt out of the sales of the personal information, and so on. So it is regulated here in the California Consumer Privacy Act. We have other acts for IoT or relevant to IoT consumer devices, like the California Act and the Oregon Act, that require security reinforcement when manufacturing and designing IoT products. It defines basic information security requirements for products, including identity authentication, data protection, and password requirements. We have another regulation, the so-called IoT Cybersecurity Improvement Act from 2020, which is relevant to all government agencies. So all government agencies shall not obtain any IoT device that does not comply with NIST guidelines before December 2022. It also gives guidelines on the implementation of the vulnerability disclosure policies for a contractor, and is applicable to all IoT devices as defined in NIST 8259. So 8259 defines, by the way, an IoT device as a device that has at least one transducer, which is a sensor and an actuator, or can be both, that interacts directly with the physical world. And have at least one network interface, and are not conventional IT, is not a conventional IT device. So even though this Improvement Act has been made for government agencies in particular, I saw also references in documentation or in tender requirements referring to the Cybersecurity Improvement Act for entities which are not government agencies, or we're not government agencies. We have the Executive Order 14028 on improving nations' cybersecurity, was signed in May 2021. And this Executive Order directs NIST to initiate a labeling program on cybersecurity capabilities of IoT consumer devices by February 2022. In the not so far future, in coordination with the Federal Trade Commission, another agency, the NIST, is required to identify IoT cybersecurity criteria for such a labeling program. A draft baseline has been already created and published in August 2021. I put a link. Sorry, I didn't advance here. I put a link here in the presentation slide. And if you're interested, so here, so you can check it out. It's quite interesting to read. The enforcement, I cannot speak about the timeline of the actual implementation of the labeling program, but it will not be in a very far future. So I would personally expect it will be done in 2022. So when you, 2 more slides, when you look in the standards and the global regulatory frameworks, it is very complex and dynamic, as I mentioned earlier. And in many cases, is where to start. Where's a good starting point to get into cybersecurity of IoT devices? So there are a couple of layers which I would like to briefly introduce. So first of all, I need to understand what my status quo really is. I have to first of all have the basic understanding on what is out there in terms of standards and regulations. What is out there in the key markets, so that I would address with my products. I have to understand also where are risks associated with my products. What are potential gaps in my design, in my processes. I have to understand also items such as the vulnerability disclosure policies. So what does it really mean to me? And I have to have the right strategy in place to address those requirements. I certainly have to understand the market requirements in terms of compliance, and to be able to set up a compliance strategy. So what are different labeling and certification schemes in those individual countries? There are schemes which are voluntary, which I don't have to follow, but I have to understand what benefit does it bring to me to ease the market entry, as an example. What are mandatory schemes so that I have to follow? What are voluntary schemes at the moment which will become mandatory schemes? I need to have, with my product strategy, with my market strategy, I have to also have a clear compliance or certification strategy in mind when it comes to cybersecurity. So what are my requirements in terms of testing in connection with mentioned standards and schemes, but also in terms of my own requirements to fulfill really high standards and best practices. My last slide is this is an example of one of the cybersecurity requirements or standards is the EN 303-645. It's currently one of the main standards for the assessment and validation of IoT products, with special focus on consumer IoT. I think it is the framework that is most recognized in the European Union, and therefore a very good reference for upcoming EU-level certification schemes and labeling schemes for consumer IoT products. It lists a couple of baseline requirements. I mentioned some of those. And also in reference to my previous slide, I have to understand what I want to do, where I want to place my product, what are kind of requirements I have, and what kinds of overlaps I have in those individual requirements. So that's an example when you look at the EN 303-645, which was basis for many other schemes as well. So when we are talking about the scheme in Singapore on the top, this Info Communication Media Development Authority of Singapore, and their technical specification for residential gateways as an example. There are a lot of requirements already from the 303-645 which are covered there. There are other requirements and a big overlap also to the US NIST 8259 standard. Really to understand where are the overlaps, where are synergies, so that I can use to develop a very effective and very efficient compliance process. And to make sure that I cover most of the standards or all of the standards, and that makes it possible for me to reach so many markets, and that I comply with current and upcoming cybersecurity requirements. So that was my last slide. My apologies for running slightly over the time. Was a lot of stuff to cover. And there might be, some time for one or the other question.
Thank you very much, Sven. You're right, we did run over slightly in time. We do have a couple of questions. I don't think we'll have time to go through all of them. So let me ask one or two and see where we can get. Okay. So the first question I've got here is with regards to the California Act and the Oregon Act. How can I demonstrate compliance with the California or the Oregon Act that you mentioned earlier?
Yeah, the California Act as well as the Oregon Act, they just specify very high-level requirements, really to implement and maintain reasonable security procedures. So that is more or less as concrete as it gets. So to really demonstrate compliance with those acts, we have to look at the technical standards that must be or should be used to demonstrate compliance with those bills. So currently, the US, in the US, the NIST 8259 is the only standard dedicated to IoT that is released by a US government agency. So compliance, so to demonstrate compliance with 8259 will also demonstrate compliance with those two acts so that you mentioned in the question. In addition to that, when we look into the IoT Cybersecurity Improvement Act that I also mentioned earlier, also this act established minimum security requirements. Again, the 8259 will be more specific, or is much more specific. It will be the standards the standards to be used to demonstrate compliance with the Cybersecurity Improvement Act. By the way, TÜV has collaborated with NIST quite a lot on the development of test methods, which are dedicated to the NIST 8259, and which can be also the test methods can be also downloaded from the NIST website. Yep. If this answers the question.
Thank you. Another question. You mentioned in one of your slides certification and labeling. Can you tell us what the difference is?
The difference between certification and labeling, a label is basically any claim that I make on a product. And such a claim may or may not be regulated by a government agency. A certification, on the other hand, is a label that can only be used if the product meets certain standards set and regulated by an agency. So it's safe to say that all certifications are labels, but not necessarily that all labels are certifications.
Okay. I think we've probably got time for one last question, and then we'll wrap it up for the day. So the last question we got is, what is a vulnerability disclosure policy?
Yeah, I think I mentioned this in one of the other slides. I think vulnerability disclosure policy is a very important aspect, and it's mentioned in I think in all regulations, in all standards, so that I have read in the context of IoT cybersecurity. And it is basically what it does. It sets the rules of engagement for an ethical hacker to identify and submit information on security vulnerabilities. So I have to establish a communication framework, so to speak, to report discovered security weaknesses and vulnerabilities. And so I have to also make the public know that there are certain weaknesses and vulnerabilities. So this is vulnerability disclosure policy is something what is becomes more and more relevant, and it exposes, I think, product manufacturers more and more, but they have to expose themselves in terms of cybersecurity related weaknesses of their products. So it becomes quite a thing now. By the way, also I think there's also training that TÜV provides on vulnerability disclosure policies. If you're more interested in that, please check it out. There's a training program available by our academy.
Okay, thank you very much for that, Novak. Sorry. Really interesting presentation, so I really thank you for your time. So that is the end of today's presentation. As we said earlier, this is the first in a series of webinars on this subject, and the next one will be available in January. So keep an eye open on your inbox for notification of that one as well. So again, I just want to say thank you to Sven and say thank you to everyone who attended today. I hope it was of use to you, and we will let you know in the next day or so when the presentation is available online for you to view at your own leisure. So again, thank you very much. I hope everyone has a great rest of the day, and hopefully we'll see you next year in January at the next webinar. Have a good day, everyone. Goodbye.
Thank you very much, everyone. Goodbye.